Hello everyone, my name is Maciej Polańczyk, and together with Michał Gałka we will present our topic, Vodka powered by Whiskeyberry PI. So for start, a few words about us.
Yeah, hello, I'm Michał, I'm software engineer mainly caring about embedded systems. If you want to contact me, there are all the details. You can reach me via email, Twitter, recently even Facebook. So that's me. You can easily tell that I'm a serious software engineer. So.
Okay, as for me, I'm Python developer. I work for STX Next, which is one of the biggest Python software house in Europe. And currently, I'm working on a web service which is connected with cryptocurrencies. Everyone wants to have cryptocurrency in their portfolio. Okay, everything about our story, which is presented today, started on PyCaribbean conference, which was on February this year. We've been there together, me, Michał, and Sebastian. And after a beer or two, or maybe five, no one knows, we got an idea of building a perfect assistant. Perfect assistant is someone who will always listen to us, and what is the most important, this assistant will pure alcohol all the time, whenever we want. So let's focus on first point, assistant who always listen to us. We are old and lazy, and we are not going to build everything from scratch. So we just check the market, if there is anything that we could use. And yes, there are solutions. We have Amazon Alexa, Apple Siri, and Google Assistant. Alexa and Google Assistant, they have Python libraries based on Flask. So this was our choice, and we had to choose one of them. We choose Alexa because, in our opinion, devices from Amazon looks better, but that's only our opinion, nothing more. And about Alexa, we have to tell you how it works. So we need a human being. Human being says, Alexa, ask bartender for vodka. And the device from Amazon is recording everything after word Alexa. Actually, it's recording all the time, but it's other case. So everything after what Alexa is sent to Amazon Cloud. It's parsed there and sent as a JSON request to the service which should respond to our request. The service can be implemented with AWS Lambda, for example, or with Raspberry Pi, like in our case. And the service has to send the response in not longer than 8 seconds, because there will be timeout. The response is sent to the user, and it's played as a voice message. So what kind of requests a user can send to Alexa? We can send two types of requests. Request which is sent to the main endpoint. We can compare it to the main endpoint of our service. And to do this, we just need to say Alexa, and then the name of our service, in this case, bartender. Or we can use one of the magic words, for example, start, launch, open, and then the name of the service. And this will trigger the response from the main endpoint of our service. The other type of request is the request which will trigger the response from any other type of endpoint, which we defined in our service. To do this, we have to say Alexa, another magic word like ask, use, tell, or many others. Then we say the name of the service, and then we say a few words which are matched with our endpoint. As for the responses, there are also two types of responses. There is a response which doesn't require any additional information. We just send the response from our service, and that's all. For example, Alexa ask bartender to pour vodka, and the response is, vodka is ready. Why not? But there is also the second type of response. For example, Alexa asks bartender to pour vodka, and the bartender doesn't know if we want juice or not. So in this case, we have a question from the service with juice, and we can answer, no, I'm from Poland. So, yeah. Then we have the last response, which is vodka is ready. Yeah, okay, so let's go to more technical stuff. How can we create our bartender service using Alexa? First of all, we need to create our developer account at Amazon. Then we need to create a new skill in Amazon. Skill is the name for the services which we can define in Amazon for Alexa. we need to configure it. So, for example, telling what are the endpoints, what are the magic words for the endpoints, what is the name of our service, and so on. And in the end, we used ngrok tool to have our public IP assigned to our Raspberry Pi. I will tell more about it later, or maybe Michał. OK, so we sign up. We go to Alexa skill kit. We create new skill. We give it a name. This name doesn't matter, at least at this point. And we choose custom setup because we want to set a few things. But there are other setups you can choose from them. So now, this name is very important. This is the name which we will use to talk with Alexa. For example, bartender. Now we have to define our endpoints. We can do it with JSON, or we can click it as you wish. What is important is the right column in here. As you can see, we have our endpoint defined, pure vodka, and we have some voice samples which can trigger this endpoint. Now we need to build a model. It takes a little time. And now we need to define our endpoints. It means that we need to tell Amazon where is our service, which will send the responses to our requests. This is why we use ngrok, which gives us public IP assigned to our Raspberry Pi board. If you don't want to buy Alexa device before you will start developing your application, you can use simulator from Amazon. It works just like a real device. It's very nice. And now we go to our service, because what we did is just a configuration in Amazon. Now we need to create our service with Flask application, with the library which is based on Flask. It's a wrapper for REST API from Amazon. So all what we need to do is to install library, actually 2 libraries. And this is half of our source code. As you can see, this is nothing more but simple Flask application. And this is the second half of the code, which is more interesting for us. As you can see, we have our basic endpoint, which responses with question. This is the second type of response. We need more information so we can send the final response. And we have the second endpoint, which is exactly puring vodka. We have only one response, nothing more, no questions. We'll just pure vodka. So as you can see, using this library is very simple, and the code is very similar to Flask, typical Flask application. Now we just need to start the service on the board, and we need our Raspberry Pi board. This is something that Michał will tell you about it.
Yeah, so Maciej has created this wonderful server, but we needed one more part. We needed to have a drink. So that was a first attempt. Well, we called it Drinkomatic. It was version 1, which was made basically, well, mainly of cardboard, a sheer amount of duct tape, some small electronic parts, 1 Raspberry Pi, and a few wires. It works. It worked. It had a few submersible pumps, but it wasn't actually the thing we needed. We wanted to put the pipe into the bottle rather than to pour it to the cylinder and then submerge the pump inside. So this is the Drinkomatic version 2. So it has the very same small electronic parts, but in a smaller form factor laying here. And it has some wires, and it has a bottle stand with the pumps attached. So let's have a closer look. By the way, this is the picture from our hotel room. So this is. So we have 2 pumps that are just sucking the content from the bottles and releasing it on the other end. There is a relay board that is connecting it, and everything is the box. So let's have a closer look into the box. So the control box for the whole device is just a Raspberry Pi, and in our case it was Raspberry Pi 2, so we needed an external Wi-Fi adapter, which is attached to the USB port. You can easily use the Raspberry Pi 3, which has the Wi-Fi built in. We have a relay board, just some wires, so it all gets power up. This fancy device is just a step-down power module. I just had one laying in my drawer, so I just used the bigger one. And that's basically it. So the idea is that we open the relay, it starts the pump, it pours a certain amount of liquid refreshment, and if it's needed, it mixes it up with another liquid refreshment, and that's it. So we needed to somehow control the device. So we used the Raspberry Pi as its brain, and this set that you see on this very table is actually self-sufficient, because Raspberry Pi is running the Flask server that Maciej mentioned. It is exposed to the internet, and on the other end, it's controlling all the GPIOs, which stands for General Purpose Input-Output, to control the relay board. And optionally, it runs ngrok. If you have the public IP, you do not need that. In this case, like the showroom that we have here, we needed to set up the ngrok that will expose our service to the internet, because Amazon needs to connect to it from the outer world. So how to control the relay board? Well, we use the pretty well-known Raspberry Pi GPIO module, and starting pouring and stopping pouring is as easy as setting up the state of the pins to low and high. The pins need a reverse state, so that's why start pouring is the GPIO low. That's stop pouring is GPIO high. So we have the dispenser. Dispenser class is set up with the amount of time that we need to pour 10 milliliters. So we can actually adjust the amount, not in time, but in capacity. Yeah, and there are just two methods. Like pour time, which opens, which starts the pump for a certain amount of time and then stops it. And pour amount, which takes the milliliters, well, calculates the seconds out of the milliliters, and then pours the alcohol or another liquid refreshment. The main class is the Drinkomatic. It initializes the board. It sets how we will name the pins, because on the Raspberry Pi you can name them as the CPU producer meant, or how the board manufacturer is meant to be named. So we chose the board, which are just simple integer numbers for the pins. So the whole, and then it initializes the dispensers. It makes sure that we will be setting the output signal on the pins, and it makes sure that it doesn't run when we start the device. Then you just need to create a Drinkomatic class, pass the dispensers to it, like the vodka relay and juice relay. Are the dispenser objects. And then you need to pass the drink recipe. Well, the drink recipe is just from which dispenser, what amount of liquid do you need to be dispensed from a certain dispenser. It is a dictionary. Well, if you need, you may need to use the order dictionary if you need them in the certain order. And then you just ask your assistant to prepare a drink from a certain recipe. This is how it works. But we had a problem. It occurs that Amazon waits only 8 seconds for response from your service. So if you have a skill setup, you need to answer in 8 seconds. So if you don't manage to do that, you will get an error. Alexa will say that something went wrong. So we have the board running, the drink is being poured, but Alexa says, well, there is something wrong with your service. We do not want that. So we just use a simple threading. We just set up a thread that's pouring alcohol and a simple queue that's waiting for the recipe. When the recipe appears, it takes the recipe from the queue, starts pouring, and sends a message to Alexa that everything is OK. We're doing what we're supposed to do. So this is just the routine that's controlling the thread. So it takes the recipes, takes the dispenser, and pours the alcohol. And prepared drink method is just putting the recipe to the key. So that's probably all for the code that's running on the board. If you want to see the whole thing, you see this on my GitHub account. So you can look at the GitHub. You can see the whole Drinkomatic without the Alexa part, but all the things that are controlling the relays and calculating the amounts are there together with some testing script. So
yes, as you can see, there are two parts of the system. There's a part with Amazon. There's the part on the platform. I work on the first part. Michał work on the second part. So we need to integrate it. We need to create integration tests. So we did. Yeah, it wasn't easy. So, OK, now I need a volunteer who would like to test Alexa. There will be drinks. Come on. Come, come, come. Yeah. Good. OK. So all what you have to do is to read from the board. Yeah, you can read.
Alexa, my dear assistant. It was
How
great.
was your day?
Oh, it was great.
Whiskey sour is ready.
OK. Here you are. That's all? OK, thank you. Thank you. Sure. OK, I need another volunteer. Because that's not all. We have more. Another volunteer. Great. Thank you. So, yeah. The start is the same.
yeah, let me put a glass.
Ah, yeah.
Alexa, my dear assistant.
I'm not sure.
Alexa, my dear assistant.
How was your day?
Great so far. It
Actually,
was hard.
Whiskey sour is ready.
OK. OK. Yeah, please take
Thank
it.
you.
So we will need another volunteer who will say, please come.
Come on.
So yes, we will need more cups. OK. So the start is the same.
Alexa, my dear assistant.
How was your day?
It was hard.
Whiskey is ready.
Oh, yeah.
OK. So. Actually, that's all from our side. If you have any questions, we will be glad to answer them, and we are ready.
Come on, no questions?
Yes?
So you said you evaluated a couple different of the voice assistants. What made you choose? You sort of said it was a little bit nicer.
So first of all, we wanted the system which will be working with Python. And actually, there were two choices, as I said. It could be Amazon Alexa or Google Assistant. And actually, our choice was just based on the device. We had Amazon Alexa in our hands, so we went with this solution. Yeah. Yes?
Curious, are there plans to expand the drink selection?
Well, to be honest, you just need a few more pumps, a few more relays, and the software is ready for that.
Yes?
So you said that you have everything on the GitHub for the Raspberry Pi part, but not the first part, which is the Alexa setup. So I didn't even know you could set it up now. You can customize it. Is there any way that you could be implementing that somehow too, like within the beginning of the implementation?
Yes. Yes, we can do this. Yep. Okay. Sorry?
Can you repeat the question?
Yeah. So the question was if we could put the Flask part on the GitHub. Yes?
Yeah,
Right?
yeah,
Right?
how you customize the Alexa part to read in your stuff. 'Cause I saw that there was a lot of
You mean this JSON configuration?
Exactly.
Yeah, we can put it. It's not a problem. We'll put it on GitHub and we'll let you know. Actually, on the same GitHub.
Yep.
Yeah, so it will be easier. Yeah. Yeah.
Is there a way for the Raspberry Pi to certify that it's an actual Amazon request as opposed to an attacker trying to pour you whiskey?
Well, yeah, I think you
Yes, it's covered by the library, so everything is protected.
Thank you.
Yeah. Yes?
Do you have an parts list that went into the Drinkomatic?
I have it somewhere. I think I have a bill of materials. If you want, just twitch me in the break. I'll tell you all the things. Sure.
So I didn't hear.
I said you could put that on the GitHub page.
Ah, yes.
Oh yeah,
Okay.
that absolutely makes sense. Well, the GitHub page was set up with the first version, and I need to update it. Yeah.
Yes.
So how long did it actually get you to set it up?
It was like 2 weekends, I guess.
Yes. So first attempt was 2 weekends, but then we made some changes to devices because we had to test different pumps and.
Yes, and
Yeah.
different pumps and valves, and choosing the right parts is crucial here.
Yes.
Does it order a new bottle of whiskey when you run out?
We can implement it. Okay, if that's all, then thank you very much.
Thank you so much.